So now we're going to get a new definition. So we just talked about maximum and minimum points on closed intervals, and sort of if it's continuous, everything was nice. If it's removable discontinuity or asymptotes, you can have some issues. We're going to define something called local extrema. And so we're going to say, f of x has and we'll say local minimum at x equals c if f of c is the minimum value of f of x on some open interval containing c. And we'll say f of x has a local maximum at x equals c if f of c is the maximum value of f of x on some open interval containing c. So we're going to look at a picture real quick and kind of see what does this mean, and then we'll say a little bit about a couple other things. So if we had a function like this, so there is some little open interval here for which this point here is the largest, so this would be a local max. And similarly, each of these peaks, I can make a small open interval. This would be the largest value of that peak, so that would also be a local maximum. And then down here, I could make a small open interval, and the y value of that would be another local maximum. Local minimum will be kind of a similar idea. I can make a little open interval here, and the bottom of the trough is the smallest value there. I can make a little open interval here, and the bottom of the trough there would be the smallest value. So these would be local minimums. So basically, if you have a function, if we had a function that kind of does a little wavy thing like that, this one would have two local minimums here at the bottom of the trough. And it would have one local max right up here. So these are, even though the function has bigger y values than the local max, it's still locally, if you look at it just a little region, it's the biggest value over a little region. So this is kind of what that word local means, is this right here, this point of this hill, it's not the biggest y value of the whole function. This little bottom of this trough down here, this little yellow part down here, that's not the smallest y value of the function. But locally, if you just look at a little small interval, this is the biggest y value of that interval, and that's the smallest y value of that interval. So kind of if you look at where these points turn around and create kind of these little hills and troughs, those correspond to local maxes and local mins. The AP course, AP test, uses the term relative instead of local a lot. So you may see stuff like, if it's asking about a relative, A relative maximum, that just is the same thing as a local maximum. And like a relative minimum, that means the same thing as local minimum. So on the AP test, if they're asking you for relative max and mins or relative extrema, that is asking you the same thing as local extrema, referring to local maxes or local mins. So the AP test, they'll use the term relative sometimes, and local other times. When I ask you questions on quizzes or tests or stuff, I'll phrase it either as local or relative to try to match up with what they may ask you on the AP test.